So hello guys, today we are going to solve a LeetCode problem. This is a easy level problem and it is called maximum subarray. I have my friend Ivanshu with me and we are going to solve this problem together and walk you through the whole process, the thinking process of solving this problem. And we will also publish one tutorial for this problem. Okay, so for this problem, we have an integer array nums and we have to find the contiguous subarray containing at least one number which has the largest sum and return its sum. Okay, so we have to find a subarray whose summation is largest. Okay, and we have to return the answer. Okay, so let me just copy this to the doc. Okay, so let's walk through the first example. Okay, so for this problem, we have to find the maximum contiguous subarray. So and it should have at least one number, I think. Okay,
Yeah.
it should contain at least one number. So if I consider elements till this, the largest subarray sum will be -2. Okay, so if we consider these two elements, then -2 plus 1 will be -1 and 1. So if we consider these two elements, then the largest subarray sum will be 1, right? And if we consider the first three elements, then it should be -2. Okay. So how will we approach this problem?
Can I start?
Yeah, you can start. Just go to the doc.
Okay, so as we have to find the maximum subarray sum, so in this problem, for example 1, the subarray with maximum sum is this one, 4, -1, 2, and 1, with sum 6.
Yes.
So one approach that everyone is getting is that one brute approach is that let's find every subarray sum, right?
Yes.
With size 1 to the size of the array. So this of individual element, and then of size 2, then size 3, and then size 3, size 4, and so on.
Okay.
But this will take it will be a brute force approach, and the solution would be of n square with time complexity, and space complexity will be 0, a constant, I would say.
Yeah, constant.
So yeah, so I think this is a very naive approach that everyone can do. So let's try to optimize this problem. Okay. So just a second. So here we are. So let's say, let me copy. Is it visible to you?
No. So where are you typing?
I'm typing my LeetCode.
Okay, I am sharing the screen, right? So you just type in the doc for now, and then we can put it up.
Okay, just a second. Let's say this is the subarray. So what will in this? Let's say index this element at index which it appear, whether this will be in my subarray or either it is will be or it will be not. Okay. And what I will do, I will add to my this element to my answer, or I will exclude this from my answer, and I will check whether this is increasing my answer, making improvement, making my subarray more or not. If it is more, then I will update my answer. Then I will include this element into my subarray. Otherwise, I will exclude. So and I will do so in one iteration. I will check with each element whether to include that element or not. If it is making my subarray larger, then that will be in my final answer, otherwise no. For that, we are going to use two simple variable. One variable is sum, to which is going
Can
to
you
be,
just make a dry run of this code, because in that way it is very hard to understand. Like,
yeah, sure. So let's say, okay, so let me start from the beginning itself. Okay, so this is the subarray, and in this subarray, the maximum subarray sum is this. So one solution is that we try to produce all the subarray in the given array and try to find the maximum subarray and store the result in a variable or something like that. So this will give me a solution with time complexity of n square, and space complexity will be constant as we are not using any extra space. So let's try to uh, solve this problem in a more optimized manner. Okay, so one key observation that in this problem is that each element, whether that element in my subarray will contribute to maximizing the value of my subarray or either it's not. So what I can do is that I can take two variable, which is int sum, which will check sum of subarray at that index, or whether element at that index is maximum than the previous sum that I have in my subarray. So which is 0. Also for the best, which is going to be my final answer. So let's say final. Let's say
this is that.
best.
Okay.
Okay. So let me store the minimum value that integer can store, as all element in my integer would be of 32 bytes. So that will work fine. So the DP is working like that. So sum, as we are containing the maximum value, whether it is the array element at that index, or whether it is contributing to my subarray, right? So this is one, and now I have to find the best solution, which is maximum of the best subarray that I have previous to that index, or whether my current sum is has increased. So these are the things that are going to work. So let me do some give a dry run and let's check on this. So let's give on this array. So for I is equals to 0, sum will be, I'm just writing using these functions or expressions and just evaluating. So array would be -2, or sum plus array element, which is 0 -2. So which is maximum of -2 or -2, which going to give me -2.
-2. Okay.
Also, and the best would be maximum of int max or sum, which is -2.
In min. That is the minimum.
Max.
That should be int min.
Yes. Yeah. Int min. And what is my sum value? Which
this will give me
the maximum of these two is -2. Now for index 1, so sum would be maximum of, just a second. Sum would be maximum of the array element, which is 1, or whether -2 plus 1 plus 1. So this is going to give me 1, and my best is going to update now, which is int min or 1, which is going to 1. So right now at index 1, I have a subarray which index 1 and sum is 1. Now for I equal 2, so sum would be whether maximum of this element or 1 minus 3, which is going to give me again 1, and my best is also not going to update, so it's going to be 1. Again, for index 3, let's again try. Sum would be maximum of 4, right? Whether it is contributing to my answer, which is, just a second.
There is some mistake.
I don't think so. I think because I have tried this. Okay, let me just give me a second. Yeah, as we can edit this video. Okay, here it would be -2, because maximum of -3 and -2 will be -2. My best will be 1. Okay, so we can edit this, or -2 or +4, right? So this is going to give me 4, and my best is going to update for 4. Again, for I equals 4, sum would be maximum of what is
-1,
okay,
-1, and
-1,
4 plus -1.
4 -1.
Yeah.
Right? So this is going to give me 3, but my best is going to be 4.
Okay.
For I equal 5, sum equal max of 2,
3 plus,
or 3
okay, 3 plus 2 will be 5.
And best is going to 5. For I equal 6, sum equal max of 1, or 5 plus 1, which is 6, and my best is going to be 6. For I equal 7, sum equal max of -5, or 6 minus 5. So this is going to give me 1, and my best is going to be 6. Now for I is equals to 8. 8. My sum would be maximum of
and 1 plus
4.
4.
1 plus 4, which is going to be 5, or my best is going to be 6. So in
The
this,
answer is 6. Yes.
the answer is 6, right?
Yes.
So I think it works fine.
So will you code it up?
Yeah, sure.
Okay. Yes.
So hi, now we are going to code up our maximum subarray problem, which is problem number 53 on LeetCode. So we discussed the solution, and let's try to code it up. So we are going to store two variable, which is sum. So now we are initializing our sum subarray equals 0, and the best answer to minimum value of integer. Now we're going to iterate the array and check for each element whether it's going to contribute in our subarray or not. Now let's check for sum. So our sum value would be maximum of whether the element at ith index or it going to increase the value of sum,
Okay,
which
yeah,
is the
fine.
subarray, or our best answer would be maximum of the previous subarray or our now updated value, which is sum. These two values take care of all the cases, and now in the end we are going to return our best solution. Now let's try to sum it. I think it's working fine.
Yeah. So let me stop the recording.